Hello everyone. Today let's solve the problem Greg and array. So you can read the entire problem. I'll just summarize the problem so that it is easy to understand. They have clearly mentioned along with the example as well. So for this particular input, we have to get the desired output. Same goes with the other inputs as well. We have to get the desired output. So I'll just summarize the problem for you so that it will be easy to understand, right? So what the question says here, Greg has array of n elements and m operation. So he has array of n elements and m operations. N elements and m operations. So each operation modifies a range of elements in the array. Each operation, this one each operation m modifies the range of elements in the array n. Each operation m modifies the elements n in the array by adding a given value. So Greg also has k queries. We have to remember one more thing. Greg also has k queries as well. So each specifying a range of operations. This query specifies the range of operations. So here it specifies the range of operations to apply. So what is our main task then? What is our main goal? Our main goal is to determine the final state of the array after applying all the operations specified by the query. So we have to determine the final state of the array after applying all the operations specified by the queries. So again, I am telling we have to determine the final state of the array. So after what? After applying all the operations that is specified by the query. This one after specified by the query, we have to finally determine the state of the array, right? So this is the question. I hope the question is clear. So let me delete this one. Let's discuss the approach and let's write the code. Let's implement the same thing within the code. So first step is, as usual, we'll be going with the input reading or input handling. So I'll just come here. The first step is always input reading or the input handling. By this time, we have to know input handling. So we'll be writing the same thing in the code. This is mostly same for most of the problems, right? So here we'll be making use of the JavaScript or the Node as the programming language, right? So next step, the core logic. Let's discuss the core logic or the initial step. So we are given n array of size n and m operations as we have discussed in the question. Each operation specifies a range of indices and a value to be added to the element in that particular range. So also let's come to the main query interpretation. So for each query, the second step is query interpretation. So I'll just write QI here. For each query, we need to apply a range of operations. So for each query, we need to apply range of this one. Yeah, for each query, we need to apply range of operations. Therefore, we need a way to efficiently track the operations that are applied. So we need some way, right? So for each query, we need to apply range of operations, right? Therefore, we need a way to efficiently track which operations are applied and how many times each operation affects the array. So we need certain way, right, for this. Why we need a way? Because we have to track which operations are applied and how many times each operation affects the array. That also we need to keep in mind. So for this purpose, we will go with the Fenwick tree or the binary index tree, nothing but BIT. So here the main approach that we'll be going with for this problem is Fenwick tree or the binary index tree. This you have to keep in mind. Why? Let's discuss the same thing. So here we need efficient updates. So that will be provided with the Fenwick tree. So we will be making use of the Fenwick tree that will provide that so that we can efficiently manage the range updates to the array after processing the queries. So this one will be going with this one, Fenwick tree or the BIT. Why? I'll explain the same thing again. So here, using the Fenwick tree, we can efficiently manage the range updates, right? So how efficiently we can manage the range updates to the array? That we'll see in the next step-by-step updates. So we can efficiently manage the range updates to the array after processing the queries. So in the third step, I just need to remember this thing. After finishing of the third step, let's come to the fourth step. Nothing but the step-by-step updates. We need step-by-step updates, right? First, we process the queries to count how many times each operation should be applied. So here, we are processing the queries to count how many times each operation should be applied. So we need this one, right? Each operation, how many times it has been applied, each operation. So this we need. Then we will apply the operations to the array in the cumulative way. So to get the cumulative sum, we'll then be applying the operations to the array in the cumulative way. So here we can say step by step operation. Step by step update, sorry, not the operation. This step we can call step by step updates. Finally, the final step is the output, right? The final result is the updated array. So we have to get the updated array after all the operations that have been applied. So after all the operations that have been applied in the fourth step, we have to get the final result in the updated array, and we'll be making use of the console log to print or output the result. So this is the final step. So this is the approach that we are going with for this particular problem. So let's write the code. I'll just delete this. Let's write the code and you get to know this one better. So first one, as usual, we'll be making use of, we'll be reading the input from the standard input stdi. Nothing but we'll be making use of the importing file stream module. So I'll just write this one const fs equals read. Sorry, not read, require, right? A require of fs. Here, I'll just consider input equals, we have to read initially. I'll just read file sync. We'll start from 0 and we'll set the encoding to UTF-8, and also we will trim the white spaces. Unnecessary spaces we'll be trimming this one. Also, we will split this one. I'll just give /n/r. We'll be going with plus and slash, right? So this is where. So after this, we will we'll make use of the counter and we'll initialize the count to 0. Why? We need to keep track of the line number that is being read from the input. We have to read the individual lines line by line. We have to read the input line by line individually. So for that purpose, I'll be making use of count and I'll be setting this one to initially 0. Let's write the custom function. Let's create the custom function readNum to read the line and convert it into the array of numbers. I can write in this way, readNum here input of, we have to read the individual lines of input, count plus plus. So then to segregate the numbers between the distinct numbers, I'll just make use of the split and leave space over here. So also we are making use of numbers and we'll map the type number. So this is fine. So next, why number? If we are dealing with the floating point integers, right? It is better to go with the numbers usually. So we can make use of the big int as well, but we cannot deal with the floating point integers if we make use of the big int, if you know. Here, you can make use of the big int as well. Here, if the input is huge or large, we can go with the big int in this case. But dealing with the floating point integers, it is better in numbers, right? So let's go with the type number here. So next step, what we will be doing, we will read the first line containing size of the array n, number of operations m, and also number of queries k. Nothing but n, m, and k. So here I can just make use of the destructuring operator n, m, and k. Here we have already we have to read. We have already created the custom readNum function. So let's read the initial array of size n. I can write in this way. Let array equals we have to read, right? Sorry. I can specify the readNum function here. Let's read the next m lines containing the operations. So operations, I'll just give OPS. This one I'll just initialize this with the empty array. After initialization, let's go with the iteration. Here this has to be I equals 0, I less than m, right? So I plus plus. Let's increment this one, and again we have to add this one and we have to read, right? So for adding, I'll just make use of push, and for reading, let me make use of the custom function read num. So I hope this is clear. So after this, what we will do, we will read the next k lines containing the queries. So this will be arrays queries. So this one I'll initialize this one to empty array. Next again we need to iterate, right? I equals, for instead of m, this has to be k. I less than k number of queries, right? So I plus plus. This is fine. Again we need to add this one, nothing but queries. For adding, I'll just make use of push, and we have to read. For this one, I'll be making use of custom function read num. So I hope this is clear. We need to close this one correctly. Yeah, this is fine. The next step is let's create the frequency array. So just give me a second here. Yeah, let's create a frequency array for the operations to track how many times each operation is being applied. So I'll just give here frequency, and this has to be this one. Yeah, I'll just consider frequency as FREQ. So let's initialize the array. Instead of normal arrays, I'll just go with the typed arrays this time. This will be more memory efficient, right? So I'll just give in uint32 array of size m. So this will be, we'll be making use of the uint32 array, nothing but the typed arrays for the efficient memory usage. Next, let's make use of for loop here. After initialization, let's go with the iteration. This has to be x comma y of queries, right? Queries come in pairs, so we are considering x and y, if you didn't understand this one. Next, for each query, let's increase the start of the operation range and decrease the n plus 1. So this is simple. We have considered frequency. Let's increment the frequency. So this has to be first x minus 1. This we need to increment, right? So sorry, I got confused here. So next one, we have to mark the end of the operations range. So to mark the end of the operations range, I can just write it in this way: y less than m, then frequency of y, this one, let's decrement this one. So just give me a second here. This is fine, right? So I'm getting confused here. Just give me a second here. This is fine. After this, we need to perform prefix sum over the frequency array to determine the number of times each operation is applied. So again, we have to go with the this one, I think, iteration, I think. Nothing but we have to perform the prefix sum over the frequency array, right? Frequency, performing the prefix sum over the frequency array means, see here, I can write in this way. Let me think that I equals 0. Oh, we'll start from 1 instead. I less than m. I plus plus I can consider. Here frequency to will perform prefix sum to accumulate the frequency of operations. I can write in this way: iterated value of the frequency, iterated value of the frequency of I plus frequency of I minus 1, previous number, right? So this one will be frequency of I minus 1. So this is fair. So after this, what we will do, we will define the class for the Fenwick tree, nothing but the binary index tree. We will define a class for the Fenwick tree or the binary index tree to handle the range updates. Let's start defining the class for the Fenwick tree. And also within the Fenwick tree, next we will be writing the method to add the value to range in the Fenwick tree. Also sum, we will write the method to get the sum from start to the given index, right? These two things we will be writing. Just give me a second over here. So yeah, I'll just come here. Let me write, sorry, this has to be, I can write in this class Fenwick tree. Here initially, let's make use of the constructor. So here within the constructor, let me consider size. So I'll just give size. I'll just set this one to size. Also, we have to store the tree values using the begint for larger numbers. So we'll be making use of the begint first thing. So by begint, we are having the large, we are dealing with the large numbers, right? So we will store the tree values using the begint for the larger numbers. So I can simply give here tree equals new. Let's consider big and 64 array of size plus 1. So this is fine, I think. Next, as I have said, we'll be writing the method to add the value to the range in the Fenwick tree, to the particular range in the Fenwick tree. I can just give add here index comma value, and here I can just iterate here. I'll just give let I equals index plus 1, I less than or equal to size, nothing but we have to use this keyword along with the size, and I equals I plus I and minus this one I, right? So this is fine, I think. This has to work. Let's see. And finally, we have to update the Fenwick tree. Nothing but tree equals tree plus value we have to give. So this one here, tree equals tree plus value. I can write in this way. So I hope this is fine. So next, after writing the add method, let's write the method sum to get the sum from the start to the given index in the Fenwick tree. I can simply write sum of, here I'll just give the name sum of index, parameter index I'll consider. Here I'll just give result equals 0, or as we have considered begin, let me go with begint of 0. So why we are initializing the result to 0? We are to handle the larger values, we are considering the begin, and we have initialized this one to 0. Again, we'll be performing the same thing, right? After initialization, we'll be going with the iteration. So this one will be let I equals index plus 1, I greater than 0. Finally, I equals I minus I, and 1 is positive, and 1 is negative, right? So here, this one to move to the next one, next one, and here to move to the previous one. So this has to be I equals I minus I and minus I. Same thing. So if you have observed the previous problems that we have solved using the Fenwick tree, for the sum, this one, this operation is same, mostly same. For the sum, build, this one, build, update, and sum, mostly they are similar. Somewhat similar itself. Not somewhat, almost, mostly this one is similar. So here I can just write, we have to accumulate the sum from the tree. This one I can just write result equals result plus iterated value of the tree. So I can write here, for tree we have to consider this keyword. This has to be the iterated value of the tree. So finally, we have to get the sum. So to get the sum, I'll just return the result. So yeah, we have considered result itself, right? Yeah, I'll just give, result. I hope this is clear. So we are done with this one. Methods add, sum, and this one constructor as well initially. So after this, let's initialize the Fenwick tree for the range updates and create an array to store the final result. So for the range updates, we are making use of the Fenwick tree. We already have written the methods as well. And we have to create the array to store the final result as well, right? These two things we'll be doing. So for Fenwick, I'll just go with Fenwick, and I'll just give new this has to be this has to be new Fenwick tree of size n. Also, we have to declare the result array as begin for the larger sum, right? So let's initialize this one result. Let's consider new begin 64 array. We have already took this one of size n. So this is fine. So next step is to, as usual, we are done with the initialization. Let's go with the iteration, nothing but we are applying each operation to the Fenwick tree based on frequency that is determined by the queries. So I'll just go with the for loop initially. So here we can write in this way: for let I equals 0, I less than m, and we will initialize the I. So here this will be let within the destructuring operator. I'll just take let L, R and D. Nothing but we are getting the operations range and value to add. Here left L, R and D. This one we have to give iterated value of our operations of I. Nothing but iterated value of OPS. So finally we will apply the operation to the range using the Fenwick tree. So here I'll just give Fenwick. For adding, I'll just make use of add, and this will be L minus 1. We are having L, R and D, right? Initially it has to be left L minus 1, and begin of D here. Also we need frequency of I. Nothing but again we have to make use of begin everywhere as we are dealing with the large number. So here it will be begin of frequency, iterated value of the frequency. So I hope this is clear. Next, after adding D into frequency of I to the start of the range, we have to subtract at the end of the range. So here I can just write the condition: if R less than n, then we will go with Fenwick dot add of R comma minus, here minus I can just consider minus begin of D here into begin of frequency I. So I can write in this way. We are just subtracting at the end of the range. That's what we are doing. So I hope this is clear till here. Next, let's come to the last step. We have to compute the result array by adding the prefix sum from the Fenwick tree to the initial array. So we'll just iterate and we will be computing the result array, right? So I'll just come here. Let me give for, we'll be starting with 0, right? Let I equal 0, I less than n, and I plus plus. So here this will be iterated value of the result. Also this will be begin of iterated value of the I. This will be plus Fenwick dot sum we have already written. We can make use of in this way, sum of I. So I hope this works. Finally, we have got the result now. Within the result, we have the result. So we have to display that one, right? For that, we'll be printing the final result array as space separated integers. So we'll make use of the join, and as I've said, it will be space separated integers, right? So let's write this one. For printing, I'll just make use of console log, and this has to be array dot from which array? Result, right? So this will be result, and we have made use of the split. So this has to be space separated integers. and we'll be making use of join, and let's leave the space over here. So this is it. Let's see whether this works or not. I'll just come here. Yeah, where is this one? Yeah, let's check with this input first. We have to get 9, 18 and 17. So I hope this works. So yeah, here instead of equals I have given minus, right? The line number 54. I'll just come here, line number 54. Where is line number 54? Yeah. Let me give equals. So let me hit the run again. So here cannot convert 10 to a big int. Where am I using 10? The result of I equals run line number 61. Let's come here. What did I do here? And this one, and this will iterate value of the result. This one has to be int of I plus Fenwick itself. I have to use the correct this one itself, right? This one it is saying cannot convert 10 to a big int. So let's see what's the mistake. So this is saying here cannot convert 10 to a big int, right? So let's see. Line number 61. This one, result of I. So Fenwick.sum, we are making use of sum here. Sum. Either we have made this one a mistake in the sum or the add. We are adding. So yeah, here in this one, this has to be I basically, right? So I have missed this one within the array I. This dot tree of I plus value we are getting, right? So not just this dot tree here. Here performing the iteration, we are getting I, right? So yeah, let me run this one. So yeah, now I am getting the output 9, 18, 17. So we are getting the correct output. Let's check with this input. We have to get the output 2. So I'll just come here. So yeah, we are getting the output 2. This is fine, right? Finally, this one, we have to get the output 5, 18, 31 and 20. 5, 18, 31 and 20. Let's see. 5, 18, 31 and 20. So we are getting the correct output. So I'll just come here. Just give me a second here. So I'll just come here. Let me click on submit. So this has to be, let's see, just give me a second here. Let me copy the code first. So I have to problem and just copy this one. So let me come and paste it here. Let me hit the submit. So no such problem this is saying. What's wrong here? What is wrong here? We are getting problem 296C. Codeforces, right? Let me type this one 296 here. So yeah. Usually we will be having that problem in the drop down, right? Yeah. Now this is taking. It's in queue. Let's check. So yeah, this is running. You can clearly see here, right? Gradient array. Yeah, I had to mention problem number as well. Here, this is showing 296C, right? So yeah, this is fine. Let's wait for some time. And we're going to check. So yeah, clearly you can see here this code got accepted, right? So this code works absolutely correct. So I had made mistake in this one, basically add, I think, right? So here, yeah, add here, this has to be this dot tree of I, iterated value of the tree. So this one I had missed, except that one, there were some typos which I fixed. So this code works absolutely correct. So yeah, this is it. Thanks for watching, guys.